Okay, so in this week, we're gonna focus on remote access and virtual private network. I'm going to have one more lab for you next week. We're gonna work on RRAS and VPN on the Windows Server side. Today, you're gonna experience how to configure virtual private network on an actual appliance. You don't have to use a large switch or a router to be able to do this. The security appliances, which is what you see with Fortinet, it has that capability. Most security appliances will allow you to integrate virtual private network, along with something like the Linksys, which is the Linksys that you're looking at. That model is specifically is a VPN router, so it is really geared for like the smaller business virtual private network infrastructure. So today we're gonna touch back a little bit on the protocols, only because, as you know, since COVID, we have regularly used remote access and how to integrate remote access in your network environment. So some of these things are going to be reviewed. Also, these protocols are going to be used when you are connecting to your appliance today using PuTTY. And so we have a couple of the services that we're going to be using. So to start, a while back, we talked about Telnet. This is a way that we can establish communication in plain text. It is bidirectional, so you're able to send and receive message in plain text using Telnet. Now, Telnet is not secure. It is not recommended to be used in a secure network environment. However, if you want to test systems, you can enable Telnet and be able to use it. So in most networks, you often see that Telnet is disabled. It is going to give you a command line interface. So you're going to see a window that's going to pop up, and it is a command line. So the way that you have one system talk to another system is through that command line interface. And you will be able to issue command or to be able to use the other system or control the other system that way. So Telnet, as you have learned, it uses port 23, and it is on the TCP port. And so another option that we should be using is your secure shell, which is SSH, which use encryption. So as we learned in the past, that we can just run telnet.exe on our Windows PC, and that allows you to execute the program and be able to set up, or use Telnet terminal. Now, for secure shell, this uses port 22, as we've learned in the past week. This allows you to use encryption for your communication, and it is better. We recommend that you use SSH. So if you are connecting to a switch, an appliance, or another system, you should be using encryption to be able to connect. Now, before, generally, you're going to see that Linux was implemented with SSH, but you can run SSH on Windows, you can run SSH on Linux, you can run SSH in systems that would support this particular port and service. So it talks about there are two versions of SSH. And when you're using protocols in the network, you always want to use the updated version if your system support updated version, only because, right, the updated version is likely having less vulnerability, less risk if you are using that particular protocol. So let's go through and answer some of the questions for the assignments today. We have about 20 questions, but the answers can be lengthy. You don't have to put verbatim. So for number one, it asks you, how is Telnet used in your local area network, your LAN? Why shouldn't Telnet be used in local area network? What protocol should be used instead of Telnet? So Telnet gives you, as you saw on page 1, a bi-directional interactive text-oriented communication facility, right? So it uses a virtual terminal that allows you to communicate with another system from your system. This is a way that we can execute a certain command. We can send a message to the other system. So before you have TeamViewer and all the other application where you can control the resources on the other system remotely, you are able to use Telnet. Telnet has been around for a long, long time. So it's allowing you to establish a virtual terminal connection. And through this connection, you're able to control your network appliances like your switch and router. So I can Telnet into my switch and be able to configure it, right? Like my Cisco appliance. I can also Telnet into another PC from my computer if the other computer has that service enabled, right? So that means that there has to be an agreement for that service between the systems. So if you don't have that enabled on the receiving system, you will not be able to use it, okay? And that's the same for all type of service, right? We have to enable it. And the way that we do that is to open the windows and door, the ports that it needs for that particular service. So what you see is, I had summarized that here, and you can find this on page 1 of your notes for unit 11. And instead of Telnet, we said that we should be using SSH because SSH gives us more of a secure communication with encryption. And so when you initiate the service, right, it activates that port, it utilizes that port. However, it uses encryption, the PKI infrastructure, in order to generate, your private key and then the public key, right? And some of you have taken 27, CIS-27, or currently in it, you probably heard about public key infrastructure. So when you're using the key, it's very much like one key is to encrypt the message, right? The other key is used to decrypt. So in the case if your key is intercepted, you're unable, the person that intercept your key will not be able to open the message, right? So the whole idea is to make sure that we have a protection in the communication, because if I'm configuring a firewall using Telnet, I'm vulnerable to someone, right, impersonating me or intercepting my communication with my firewalls, which is a security appliance for my network environment. But if I'm using SSH, it's going to establish secure communication between my system and my firewall, right? You know that a lot of the administrator, we configure the system remotely. You might be at corporate office and you need to configure the appliance at a certain region in a different area of your network that could be geographically far from where you are. So as long as you have communication via the internet and also connecting to the network, you're capable of configuring or reconfiguring your system using these type of services such as SSH. And you want that to be secure because anytime that you travel over the public network in order to connect to your private network, you should always implement security in your service, right? So it talks about that. Now, SSH can also be used in connecting your client to your server, right? So you have learned how to configure DNS, DHCP, those are server role, but the system that you're using to do your schoolwork and your lab work is a client system like your Windows 10 and Windows 11. It is connecting to the domain and it has joined the domain so that way it can utilize the resources in that particular network. So what we can do is we can utilize SSH to connect the client to the server. And as long as I said, having that port established or enabled, so SSH uses port 22, whereas Telnet uses port 23. So if you enable port 22, and you can use SSH1 or SSH2. So how do I know, right? You can check for the version of your service that's used. And you can check for the service in Windows PC. You just simply search for services console, open that up and see if that service is enabled. remember that every single service needs an open window or door, right? That's how the system is able to exchange information and data is through that, the services that's established for that particular window and door. So it's tied to port 22. And we want to utilize either SSH version 1 or version 2. So if you have version 2 available on your system, then use version 2 because likely it is a better service than your previous version. They have upgraded it for a reason. A lot of the times it might have additional features along with better security, right? And then the applications that you would use so that way you can remotely log in. So today you're using PuTTY, right? PuTTY is a common application that you would use to connect to through the terminal. It creates a virtual terminal to the system. It's like how I would be able to go to your house, but instead of physically go to your house, I'm able to see your door and window and then virtually go to your house, right? So in order to connect to the system virtually or remotely, I would need an application to do that. So you can use it through command line. Some application would also, almost all applications going to open up the window that you're going to see command line interface. And when you look at something like TeamViewer, it is a way to remotely connect to the system or remote desktop services on Windows. You can physically see the desktop on your screen, right? But we are connecting it remotely through that particular window so you can see. You can navigate and you can control depending on the level of access that you have remotely. So we would use the software, a tool, an application that allows us to connect to the command line, right? We're gonna then log in using an account and a key. And then we are going to, once we are successfully logged in, we can then execute command. Like, for example, I want to configure the switch so I can, go through and I can do, config term and navigate through the actual command line interface for the iOS. And then I can set IP addresses, I can configure VLAN, etc. So you're gonna see some of that today. You're gonna connect your PC to your appliance, and then you will be able to navigate through and configure your network services that way. Okay. Any question regarding SSH and Telnet? So the practice in the IT world is that we don't use Telnet in a realistic environment. We want to use Telnet only when we want to test, right? If you want to have more security, you should implement SSH. SSH is the way to go. Okay, so originally, like I mentioned, SSH was used in Linux, but it became very popular, right? And it should be used in across multiple type of system. For Windows 10, you see that OpenSSH is implemented for Windows environment, so you can use SSH. And when you start using SSH, you would see that it's going to require for you to generate a key. So you have to have the key in order to, authenticate and access the system through SSH. And you can find this information from your notes for today, Unit 11. Any question regarding these two services and protocol? So you can find that here. Okay. All right. Next, we're going to talk a little bit more about the other two. So if you are specifically using Windows system, you are going to use remote desktop. As you know, that cloud is common now, right? Everybody has cloud. Everybody usually have infrastructure on the cloud because it's cheaper to lease somebody's server racks, right? So at AWS or Azure or in some data warehouse, data center, and when you're connecting the system, you are going to use RDP, and this is specifically proprietary to Microsoft. So I used to write labs for my students, and you might see that in other classes with Azure and AWS. And then when you pull up your server as a virtual machine, as an instance on AWS or Azure, you are going to use remote desktop because your Windows PC system needs to connect to that server in order to establish the communication. So what it's going to do is the server is going to listen at this port. It's 3389 if you're using TCP or UDP, okay? And in order to access it, RDP requires that you have a key, and you would use that key to access. Now, RDP, is it 100% safe? Nothing is 100% safe, right? It is as safe as how your key is secure. If you're familiar with VNC is it's not safe, right? I use this when I teach Raspberry Pi to students in non-credit classes. So you can install an application called Real VNC. It's free. And one system, like my Raspberry Pi, needs to be the VNC server. And then my laptop, which runs Windows 11, is the client. So in order to configure the Raspberry Pi, I need to make it a server as Real VNC. So as you know, Raspberry Pi already has this installed. It also has SSH. So if I don't use SSH, I can use VNC. It allows me to access the desktop remotely, similar to what you see with TeamViewer or other desktop application. So it is platform independent. That means that we can use this across platform, and it is built with Java. Okay. And then you can also utilize like a web-based type of environment. All right, so we talked about SSH and Telnet with the first two questions. Sorry. For number 3, it says Gabriella wants to connect her Windows 10 system to another Windows system using RDP. How can she accomplish this task? So an interview question would be, right, if the job requires that you know how to manage remote desktop environment for Windows system, they might ask you, how do you use RDP, right? We have to know how to be able to set it up. So on her computer, Gabriella would open remote desktop connection by searching for remote desktop connection in the Windows search bar. That's the first step. Then it's going to give you the option to click the menu and enter the IP address of the destination system. So her system is system A, and she needs to connect to system B, right? So at this point, after she had select the option for remote desktop, she's going to then enter the IP address of the system B, the destination system. And this could be, right, at another network, right, at another location geographically, in another area of the local area network. So typically, you can also search for it instead of an IP address, and this ties back to your last week concept and lecture. You can do name.domain name. The name right here is your system name, okay? So if it's a server, that will be your server name right here. Remember how we looked at that last time when we set up DNS? And then we're going to do a dot and then the domain name, like abc.org, right? mycompany.com. So whichever the domain that she's trying to access and the system of that domain, so it will be like computer@contoso.com. Microsoft, they like to use contoso.com, but you can see, so your system name, and this goes back to what we talked about with NetBIOS, right? And also your domain ties back to your DNS. So what you see is that you have these services enabled on your Windows Server system. As you set it up, you will be able to navigate to it remotely if you are connecting using RDP. And this is how we can establish the connection for remote desktop. Do you have any question for me? So make sure if you put RDP down on your resume, make sure you know how to configure RDP, right? So you would need to put in the IP address or the system and the domain name in order to, and then you just click connect. And through your physical network or through Gabriella's network, she's able to navigate to system B this way. And if she's successful, usually it requires her to authenticate, right? And be able to put in that information. So once she had that information put in for the user account, then it's going to open up the desktop of the system B. That's how we're able to remotely access. So when I talked to the employer, when I went to the meeting last week or almost 2 weeks ago, they were saying that, you know, your students needs to have more practice in that kind of support to remotely connect to the client system. Even when you do threat hunting, when you're doing analysis on the actual server, right? You need to be able to understand the process and know how to connect either via SSH, RDP, or even Telnet if you're testing. Okay. Now for VNC, as I mentioned, you are going to use Real VNC. It's an app that you can install. And this app needs to be installed on both systems. One is going to be the server, that's the destination system. And the one that you're using to access remotely is going to be the client. So for number 4, it says Adam wants to use VNC to connect to the Windows PC, his Windows PC to Ubuntu Linux system. To control the Linux system, describe the steps that he must take to establish the connection. So first, he needs to go to the website, and you can Google this. You can just say VNC download, right? And it's going to take you to Real VNC. It's going to give you the first hit on Google will likely be Real VNC. You need to visit the website, and you need to download and install Real VNC on the Real VNC viewer, right? So if we're using system A to access system B, system A is going to be the viewer, okay? System B is going to be the server. So Adam's system, the Windows PC is going to, we're going to install the Real VNC viewer on the Windows 10, which is a client system, okay? Then on the Linux system, you can use command line, which is the terminal, and you can install what's called OpenVNC. So Real VNC, technically it uses OpenVNC, just like how SSH uses OpenSSH, right? These are free products and open source products and tools for you to use. So on the Linux system, we need to make sure that OpenVNC is installed and enabled, right? Most likely that you already have installed. Just like what you've done with Kali Linux, I recommend that you do an update first, okay? And then from your update, you would then install, and these are the process. So first, you need to install the dependencies for this package. Then for Ubuntu or Debian, you need to install what's called Type VNC server. Now, if you don't know how to do this, go to OpenVNC. They have instructions for you how to get started. So read how to get started or get started instruction on the website. And then once you have it installed, you have the command issue, then you execute by typing in VNC. Just make sure that your directory and everything is available, because if you're getting an error, right, that just means that you're not in the right path. You know how it is to troubleshoot Linux. You've done some of that when you were working on your wireless adapter last time, right? So Ubuntu is very similar to what you've seen with Kali, which is a Debian release, right? What you see is you're gonna use similar command are almost the same. So type VNC server is the one to go. So we're gonna install that and then we're gonna execute it by using VNC server. So at this point, what's gonna happen is it's gonna activate the Linux system as a server. And I already have my Windows system as a viewer, so that way I can locate the Linux system from the Windows system by putting in the IP address, right? So next we're gonna locate the IP address of the Linux system, and you just do an IP address command. Write down the IP address on your Windows system, then you're gonna put in the IP address on the prompt that it's gonna give you. I should have brought my Raspberry Pi so I could show you, but I wanted to set up your lab today, so. Okay, so if you want to practice, Raspberry Pi is also a good tool to be able to learn Linux commands and be able to learn remote access. Do you have any questions for me? There's more steps to this, so I just want to make sure that, because I see a lot of you are still writing down the information. Okay, let me move 4 down, or 3, maybe 4 to the next page, or maybe, let me see if I can move D up. Okay, that's probably better. Okay, so the last step after you find the Linux IP address is on your Windows PC, open Real VNC application, because you just installed it in the first step. And when you click connect button, it's going to give you a little window where you can type in the IP address, or you can also put in system name and the domain like what you've seen, but IP address works best. Then it's going to prompt you the username and the password of the Linux system, the Ubuntu system, and then once you authenticate. So if we were to remotely connect to Kali, then you just do Kali and Kali, right, to log in. For Ubuntu, whatever the account that you set up, it doesn't need to be a root, right? As long as it's a legitimate account and it has access, then you just put in the username and the password after you put in the IP address, okay? If you successfully connect, it's going to give you the desktop of the Ubuntu system if it has a desktop. You know that Linux, you can install Linux systems without having a desktop. Same thing with Windows, especially server, okay? So if it doesn't have a desktop, it's going to give you the terminal, then you can run the command that you need, right? Like you can check for a certain type of versions. So in the case of security, we can run things like security tools. You can install things on there. So if someone is able to connect to you remotely, if your VNC is available, then they can connect remotely. Now, for a malicious user, they would then be able to access your command line and be able to execute commands and install things or run things, scans, right? Or launch an attack this way. Do we want to be able to do that? No, we want to make sure that we're protected. So in my opinion, VNC is not safe, but it is definitely convenient if you need to remotely connect. I typically use this when I have to connect to my Raspberry Pi desktop. Now, I can't access the desktop environment if I'm using SSH, okay? So if I want to click and point and be able to run some application, like when I'm doing, I usually teach kids on how to code with music, like create synthesized type of sound clips, like, you know, making beats and be able to combine a lot of the elements to make sound through coding. So stuff like that in Raspberry Pi class, right? Then I need to be able to access the application on the desktop. So if I run SSH, it's only going to give me the terminal, and the kids, they won't know how to be able to navigate through it. So I would need to use something like real VNC or VNC. Okay, any question? Okay. So make sure we know the steps, especially if you're testing for an interview or you're going for an interview. They want to know how you will be able to connect, right? So on the notes, it keeps talking about different type of protocol. We talked about FTP, SFTP before, right? For file transfer protocol. And then out of band management, which brings us to the next question. So this section, it talks about devices for connection. So today we are going to use a console cable for Fortinet, okay? Cisco appliance and network appliances use console cable. The standard console cable is what you see in front of you on top of the Fortinet box, the blue cable. This looks like an Ethernet connection. It is an RJ45, but the way this cable is made is special, okay? This particular cable has a chip inside here that converts the signal, which is in your communication, which is for your copper. It converts it into a USB ring. That allows your system to be able to directly connect to your appliance with this. So most of the standardized network appliances either use USB-C, right? But the console cable is typically an Ethernet connection still. You will plug this in where it says console, okay? On the switch, the router is typically in the back of it. I don't know why Cisco put it in the back. A better design should be to leave in the front. So some of the newer routing, you see that in the front because you need to see the lit light when you connect into it. Almost all appliances have it in the back. Maybe it's just because the way that the power is set up. So you plug this in where it says console, right? And today I need you to work with your neighbor who sits next to you because I don't have the appliance. So this is a security appliance. It works as just a filter system like your small firewall. You can create virtual private network this way. When you look at it, it shows console. That's when you plug in. All network appliances should say console. Do not plug it into your regular Ethernet connection, understand? Because this cable is not designed to convert the signal in these ports in your typical Ethernet connection, but it's only able to read where it says console. So you take this, you connect it here, and then you take your USB-A and you connect it to your computer. And this is how you're able to use your application, which we talked about, to be able to manage this system. You're going to terminal in, you're going to remotely access the system from your Windows PC. Okay. Now, some of the appliances will have, actually have a software application for you to use. And then most of the appliances will still allow you to access command line interface. So today you're mainly going to use the command line interface to be able to configure VPN. That is very short. And then you're going to also learn how to configure VPN on your Linksys VPN router. Okay, any questions? Okay. So console router, you might have a console router. This is going to connect to the console port. We talked about this already. So we need to connect to our switch, router, and security appliance with the console port and with the console cable. Typically, they're blue, sometimes black, okay? The old school way is to use auxiliary port, AUX. When do you see this? You see this in old networks. How often do you see this? Kind of rare these days, but you might go into a business environment that they might still have some kind of modem, okay? Kind of rare because, you know, I've seen some mom and pop shop. So whenever I go and I pay for something or I'm checking out at the store, I'm always looking at their systems, right? I would be looking like what kind of system they're using, how do they connect. So in an older network, you're gonna see modem. Okay. Now, modem is used for slower connection, and you can access those using Telnet or SSH. PSTN, you see this, we talked a little bit about public switching phone, like at the elementary school, you know, the PBX system. But in the old network, our telephone network back in the day, if you watch like, you know, the old TV shows, the people used to be in the 50s, they would manually switch, right? You have these ladies that work at these switching network that they manually take their hands and plug things in. And then later on, they converted that to an analog based type of switch. And then eventually those went away. And now we have everything digital for voice over IP. So in the next few questions, we can say that number 5, how do you manage a modem that is out of band and cannot be connected via the network? You would use AUX port, and this allows you to connect remotely using Telnet or SSH. Okay. So when you troubleshoot a modem that is out of band, we would use auxiliary port on that particular system to be able to connect. For 6, identify the types of modem that used to connect to remote network PSTN line. So maybe one day you might go internationally, you might go work in a country that still might have like the older network systems and the telephone systems. They're part of the world that they haven't fully integrated into some part of the network. But in that case, you are going to use an external modem, which is a separate device. I think on the notes it shows you what that looked like, right? And you would connect that device to your computer or to the other system. Then you have the internal modem. Some of you probably have seen this in the past. This was really popular in the 90s. It has a telephone connection on the card, and you would install that card, right, onto your motherboard. That's called an expansion card. So what's the difference between an internal modem and a network interface card? A network interface card has an RJ45 connection, which is a larger connection, whereas a modem, it uses analog signal, so it has the telephone connection, which is the RJ11. Okay, so when you look at the telephone line, maybe your home still have it, or when you go to your grandparents' house, they might have it. The telephone line, it uses the RJ11 connector, which is smaller than your RJ45, right? And it is a smaller cable. Okay. So the internal card, it goes into it, you would install it onto the motherboard of the PC and be able to connect. Whereas an external modem, it's actually a box, right, that you would connect via its cable from the outside. Okay, so that's 2 ways that you can use the modem. Now, so you say, why are you telling me this old stuff, right? You might run into legacy system and you have to troubleshoot it. You have to know how. Not every company's automatically upgrade to something new. They might have some part of the network that's older and you have to troubleshoot it. Also, if you're looking at remote access, for Windows Server, if you look at the prompt, it actually gives you point to point, which is what we use with dial-up. And back then you can only establish 10 connections at a time. So it's able to connect one system to the next system and that system to another system. And that's how we used to remotely connect. And Microsoft kept that on. So when you go through the wizard, you still see it with RRAX, with your remote access server. Okay. Now, some company, they might have a dial-up still, right? They might have an analog line for a backup. So that means that in the case that if everything goes down, they would use that even though it's very slow, or they might have ISDN. ISDN is kind of, a little bit older and long gone, but what you see is you would see that, some part of the world, they still have that as a backup option. Okay, yeah. I'm sorry, say it again. Add the band, we talked about, how there's certain band that related to channel, like certain type of bandwidth, right? When we talk about wireless. So in communication, you would have signal that is range in a certain numerical value, and that belongs to a certain channel. So when it's out of band, it's not able to communicate. Just like how when you're listening to the radio when you drive, and when you drive far away from the radio broadcast tower, you're out of band. You don't have signal, right? And that's more on like the wireless line to site kind of issue. But in the case where it's not able to receive signal because it's not linked to the appropriate channel, or it's not communicating by sending in that certain range of signal, then what you have is you have to configure it and you have to troubleshoot it through the auxiliary port. Okay, so for ISDN, you got tier 1, tier 2, and tier 3. Most popular in the early 2000s, what you see is tier 1 and tier 2 for most business. They used to have to pay based on data transfer rate, just like how you are paid for your data with your mobile devices these days, right? And also sometimes by the amount of time that they use it. So some company, they would use certain tier to synchronize data that's proprietary, and then lower tier to be able to implement for regular usage. And you can have a dedicated line. That just means that you would use that particular line for specific things. Can someone have a dedicated line for the network? Sure, right? It would require a lot more in cost and installation to be able to do that. If you want to be able to have those systems regularly communicated. So in ISDN and tier 1, these were used to go point to point. So when we say point to point, is going to be one location of the network, that one system to another system in another location of the network. And it established that direct line or the digital path for those systems, so that way you can reserve the bandwidth for that system. So let's say that I own a bank, and my transfer for my account, my databases, for my financial systems are critical, because that's people's money, right? Investments, loans, etc., or even deposits and withdrawal. So what I can do is I can have a dedicated pathway for my databases across my branches, from my corporate office down. So if you're looking at Bank of America, their corporate office is in Dallas, Texas, I believe. And then you can branch off from there to be able to go to different region. So they might have, specific data center that they set up. Back then it was data frames, mainframes for their data center to be able to. So it utilized the priority of the bandwidth in that dedicated line. It's kind of like, how you have the private highway to go and you pay for that, right? So just imagine that you pay for your own road and you can just go down that road with no other cars, right? So that's kind of like the dedicated bandwidth that you can use. And so the speed of this digital line, you can go up to 2 gigabyte. And then you look at this and you laugh. You're like, well, 2 gigabyte is not a big deal, right? But it was really a big deal for the business back in the day. Okay, so for number 7, we can describe the channels that use in ISDN for voice and or data. And how was this established? So if you look at the next section, it talks about ISDN networks. Just like A plus and Security Plus, you are gonna receive randomly drawn questions from a pool of questions. There will be questions of the most recent technology, and there will be questions for legacy or older technology. And you must know ISDN because ISDN was the main type of communication for, I want to say, the last, the early 2000, and that was used. Okay. So, so it asks you how many B channels can be used, and I think we had an assignment where we talked about this also. B channel can be used for 1.5 megabit per second on H11 in ISDN network. So channel B is used to transfer data. And back in the day, what you see is for each channel, you get 64 kilobit per second, which is what they call a bearer channel. Then they use a channel D to be able to handle the signal, which use 16 kilobit per second or 64 kilobit per second. So you have two separate channels. One is for data and one is for signal. The reason why they do this is this channel is going to establish, it's going to send signal for the other channel to transfer data. Okay, they always go together. So channel D enables channel B to pass data. And then D is used to remove administrative overhead for B. You don't want one channel to do both because in that case, we are going to slow down the transfer in the data rate. So in ISDN practice, you would set up channel D for channel B. D as in David and B as in boy. Okay. Now, with the bandwidth that is available in channel D, it really depends on the type of service. And you see this in A plus and you see this in Network Plus. BRI is 16 kilobit per second. So if the business acquire BRI ISDN, their channel D is at this rate, 16 kilobit per second. But if the business, they pay a little bit more and they acquire the service for PRI, which allows them to have a higher throughput for the D channel, which is 64 kilobit per second. So how am I going to be able to achieve 1.5 megabit per second from 64 kilobit per second? You do a multiplier. That means that I have to take 24B channel, combine them to be able to achieve 1.5 megabit per second. Okay, so if you do the math, if you convert this into kilobit per second and you divide that by 24, or how do I know how many channels? If you take this and divide it by the rate, you get the number of channels. And that's how we were able to calculate it. Okay, so make sure you know this for final exam and quiz. You will see that on the final exam and quiz. So 24B channel, this is for data. It's going to be used to make up what they call H1 to achieve 1.5 megabit per second. And I experienced this. So 1.5 was fast for its time, right? Because most people, most residential, you're going to double this at the most, even with a modem, okay? Even with DSL back in the day. So you have a dual channel for DSL, and that's 2 times 64 kilobit per second, which gives you 128 kilobit per second. So most people's home was transferring at 64 kilobit per second or double that at the most. Okay. That was the dial-up day and then the beginning of DSL. And so what you see is that for business, they're able to get 24 times that, which allows them to transfer data a lot quicker. Any question? Okay. For 8, how many B and D channels are used to facilitate communication for PRI, primary rate interface, to derive 1.5 megabit per second or higher transmission rate for the US and Europe? So in the US, it's regulated to be used 24B channel plus 1, so that gives us 24. That's what we talked about. D channel, and that's going to give us 1.5. So what we just talked about in the previous one, that's for United States. In Europe, because of the regulation in Europe is different, and you see this across a lot of different things, right? If you're in my forensic class, we talked about that too. There's certain things that are acceptable and not acceptable in different part of the world. So in Europe, 30B channels, so you're able to get 30B channel plus 1, so that's going to give you 31, right? So if you take 30 times 64 kilobit per second, you get the rate. So it's actually top out a little bit higher, 1.9 megabit per second, goes close to almost 2 megabit per second. So in Europe, they are able to transfer a little higher because they have more channel that they can use for B. Any question? So we're halfway through, and then there's 20 questions, so we just kind of get through these. Okay, after you see ISDN is on the bottom of page 2, going to page 3. Okay, it talks about different types with PRI, and then so North America and Japan is close, so that's what you see, and this is where I found the answer for the other one. So what you see is you can go to page 3. So that's going to give us 1.5 megabit per second, whereas in Europe it will be about 1.98 megabit per second because they have more channels that was allowed. And so in the image, it shows you the standards and also the protocols that were used for ISDN on how this is integrated. And then, so it breaks down to like, what is an NT1? NT just stands for network terminator. And so you would have terminator 1, terminator 2, sounds like a movie, right? And then for the last system, you would have the TE, which is your terminal equipment, and you would have equipment 1 and equipment 2. So it gives you the differences in these type of systems and how they would be connected for ISDN, and you would need to have an adapter to connect the TE2 to the ISDN. So there's certain requirement on components and systems for connection. And then it talks about different identifiers. So, that would allows you. So how did they come up with the phone digit numbers, right? Remember how the area code, some of you were too young for that, but your parents might tell you that area code was really important, right? Like, for example, 909 was the Inland Empire before 951 was integrated for like the Riverside area, right? And then 909 came to be more east of it. So what they did was they actually use it tied back into how the network was established. So you have the DN identifier that gives you the phone number, and then you can have up to 8 DNs assigned to the device, and this is what you see in the communication network. And then through that, what they would do is they would use these numbers for businesses, right? Or the network for the businesses. And then if you're using the VRI, you can have 8 devices, which gives you 64 directory. And this is how people would have like their extension, which is what you see today, for like the numbers that were in the subdivision of that business. And then from there, you would be able to implement like characters in the DN and all of these things that would be assigned specifically for the subset of those telephone numbers and so on. And that's how it was established. Okay. So read through that, kind of interesting. Historically, how we design it and how we integrate it throughout. time and be able to support and change that completely to something that is more efficient and have more throughput. So we have improved. Okay, the protocols that are used for RAS, remote access service. Okay, there are different types of protocol. In communication, you would use something like SLIP, which is serial line internet protocol. And the newer integration for this is going to be point-to-point protocol. So next week, when you're configuring RAS, you're going to see this. You're going to see point-to-point to point. So PPP, the triple free protocol, is really used for remote access integration for Microsoft. Okay. And so you would then, this originally was using a modem, and you can still use the triple P without the modem, with network interface card, right? But the limitation with point to point is that it lacks security and is very limited to the number of remote access. We cannot scale for COVID with PPP. So what happens during COVID is a lot of the networks were not ready for remote access. You know that. Businesses. So when people started to have to work from home, there were a high need for IT people to be able to support that, period. And it still is, right? So since COVID, we would now see more hybrid environment and more remote access type of integration for or support to be able to make sure that there is communication for the employees. So SLIP is the older protocol, and then the PPP was implemented also older, but newer than SLIP. So when you're using PPP for remote access, what protocols can be used for authentication? So when you use remote access, it's important that you set up authentication accordingly, right? So one, you can use PAP or PAP. This is for when your client authenticates to its server by just issuing the username and password. So it's going to send the account, the credential over to the server. And what it does is it matches the information. And so the system would then wait for that to be able to capture that. So if you're using PAP, you're vulnerable to sniffing. So if I run Wireshark, and if you're using this, I see all your credential in plain text. Okay. So we want something more secure. Later on, a lot of the server systems, right, OS, start integrating like chat or MS chat. Microsoft integrated MS chat. So for CHAP, it uses encryption to be able to protect that credential information by being passed. So typically when you log in with your username and password, your credential is then passed to your authentication server. It does a comparison. Is it a match? If there's a match, right, your SAM, your security agent, would then issue you a token to be able to say, this is what you're allowed to do on that system and on our network. So CHAP was a little bit more in security because we have encryption implemented. MS CHAP is also similar to what you see with CHAP. And this is for Microsoft. So it implemented a hash challenge along with encryption to be able to establish a session with the authentication. So the password is encrypted when it's stored, and this is what you see with what your server system and also your client systems now with Microsoft. And then there's different versions of MS Chat, right? So your password is encrypted when it's stored, and it would use a hash challenge. So the hash allows us to know that the session is original. Hash typically is a way that we can do a comparison, or the system can say that there's integrity, right? There's not been change in that particular session or any kind of modification in the credential. Any questions? Okay, for those of you who learned about Kerberos in CIS 27 or another class, Kerberos is still going to come up because this primarily used by Microsoft, but it's not really for just Microsoft, right? So Kerberos was later implemented. This is a mutual authentication protocol. It allows the server to authenticate the client. This is using a ticket granting service, and that client is granting a ticket to access the server in a certain amount of time. So my analogy for this is like an amusement park. You buy a ticket to enter the amusement park for that day, right? Like Disneyland or Magic Mountain or Knott's Berry Farm. And when you buy the ticket, they give you a little wristband, and using that wristband, you're able to access the amusement park accordingly. The next day, you're trying to use that wristband to re-enter, and they won't let you, right? So that ticket granting service, it's really tied to a certificate that is for authentication with the credential. So if that expiration is not matched, right? The date that is granted. So if I have granted you access for the last hour and you're trying to access later on, you won't be able to have that because it's only going to be for that session in that period of time. So we're able to control it more. But when this first came out, right, Microsoft claimed that Kerberos is strong. It is better than not having any kind of authentication. It's also unbreakable, etc. And then a few days later, golden ticket attack came out, and there goes that, right? So is Kerberos 100% foolproof? Nothing in security is 100% foolproof, but the process is that to be able to have a server that looked at your ticket, which is also tied to your certificate authority, there are multiple entities that's managing the components of your authentication. So that way there are hurdles in that if someone needs to attack it, they have to be able to modify multiple things in order to access. As you know, in security, we implement multiple things to buy time, and that allows us to be able to keep accountability for the authentication in the amount of time. Okay. Yes.
Which one is the one that checking credentials for Carol or is that SAML?
So Sam agent, the agent for security is just a way that we can implement security token. So Kerberos is used for authentication checking, and SAML is a way that we can control access after it authenticates. Yes. So after I successfully authenticated, I would receive a security token, and that security token would allow me to access certain resources. But Kerberos is the service that we would use for mutual authentication. So that means that the server and the client needs to agree at when it authenticates. And CIS 27 talks about that. Okay. So protocols, you can refer to page 5. I think we talked about NetBIOS and NetBEUI a while back, but there's also network control protocols for IP modules and link information there. Triple P information, so there are processes in using point to point to point. CHAP and MS CHAP is on page 6. And I know some of you have attended ZetaSky, right? The summit when they held it last month, and they showed you on MFA, multi-factor authentication, how easy it is to be able to attack. Yeah, everybody uses multi-factor authentication because it's just an added level to what we didn't have before, right? So having the extra level just buys you a little bit more time, but does it mean that you are safe or not? Not necessarily 100% safe. Nothing is safe, right? In security, we just implement things just to slow things down ultimately. So multi-factor really capitalize on something you know, something you have, something you are, and somewhere you are. So you are combining multiple of these things so that way, in the case that if they have your email account and they impersonate you, right, you're able to have other things like your knowledge, your biometrics, so that way it's not easily accessible. It's just an extra step in order to prevent someone to easily access your account. That's it. But is it foolproof? Nothing is foolproof. This is why this industry always demand people and resources, right? So, and then Kerberos, you can find that on the next section, which is on page 7. Okay. So let's talk about synchronous and asynchronous. We want to make sure we know how these terms are defined for the modems. So you know that if you're using DSL, I know people still use DSL in some part of the area, right? If you live in a rural area, even if you are rich and you're willing to pay for the service, you might be able to pay engineers to come out and dig fiber line and connect that for your neighborhood or for your mansion. But if you don't, then you just have to use DSL, and DSL uses modems, okay? So you often see that when they sell you the package, they just say DSL because most people don't know. There's asynchronous and synchronous DSL, okay? Synchronous, for asynchronous, data is sent separately and it relies on node to be able to send and translate by bit order. Where synchronous, data is streamed, okay? And it uses clock signal to interpret from beginning to end of the packet. So often you see a lot of your DSL packages fall under synchronous, okay? But you do see some cases where they actually sell you asynchronous DSL. So these are the two different things. Asynchronous, data is sent separately. Synchronous, all data is steadily streamed and it is using a clock signal in order to control the rate. Okay? Okay, there's a section for troubleshooting point to point to point, and then it talks about PPOE, right? Over the Ethernet options, and then your modem information is here. So the modem, it encapsulates your data and it passes your data, and this was used with the analog or the landline, and you do see some rural part of our country still have this, and it talks about asynchronous and synchronous DSL modem right here, okay? Okay, so for remote access, what do I need? If you need to really think about planning out your remote access server and that part of your infrastructure, what do I need? First, my client system, my laptop, my desktop, my systems that are connecting to the network. It needs to make sure that it has the configuration. So if you're using like modem or dial-up, you have to make sure that you have the connection number or the server information and the service that's used, right? We talked about RDP, right? We talked about SSH. So the protocol and the service and the port, so you need to configure your client system and they need an account. So it doesn't just magically happen. Somebody has to configure this, okay? And you could be that person. Okay, let me move 12 down so we can see the next part. We're almost done. Just a few more. I know it's a little lengthy in the answer. Okay, so we talked about the first bullet. The client has to have the setup information, the configuration. then you need a server. So if you're using Windows Server environment, you have to install the role, which we'll probably see. I'm gonna modify the lab a little bit so you can do RIS with VPN next week on that. But to successfully do this, you need to have a public IP. So we might not have a complete lab with just some configuration. So your remote access server, you have to have the role and features for that. So you need to install that role and feature on the operating system. You need to enable access. So we want to make sure that we configure it for point to point to point, or we can, set up other type of format to be able to connect. You need an account to be able to access, right? So you have to set up a user account. So sometimes it would be a valid ID and password or a user account on the network. So you have to create an account, put it, I normally put that in a group and control the group permissions that way. And then if they are using ISDN or DSL for connection, they need the hardware, right? So that means that they have to have a way that I can connect the cable, or I can connect to a device, like we talked about an external modem to be able to connect. If I'm wirelessly connected, my modem has to be wirelessly accepting the signal, right? And then you need to have protocol for access. So we would look at the network layer protocol for the setup. Any question regarding the requirements for remote access? So today we're going to focus on VPN, whereas next week we'll look at also VPN, but also focus on a little bit more on RIS, remote access server. Okay, so point to point to point were popular for its time. That was the dial-up modem era, right? We moved on from that. We want to make sure that we can provide remote access with virtual private network and be able to protect the communication for these systems. So later on, there came a protocol called point-to-point tunneling protocol, your PPTP. So the hard part about networking is there's so many protocols that you have to remember, so many different technology. I recommend that you chip at it a little bit at a time, right? Read about it, trying to remember something about it so that way it would help you with certification, just like A+. There's a lot of like technical terms and details that you have to remember. So PPTP give you a way to securely transfer data better than point to point protocol. And it would allow us to be able to set up a separate server and creating what you see with VPN. I know a lot of you already use VPN. You use VPN as a service via internet connection. So for example, you might be using it with your anti-malware software or security software. You might be using a internet-based service, and you might pay like $10 or $100 a year, $10 a month, etc. But we can set up a virtual private network so that way when we connect, right, people cannot see the activity that our users are experiencing or doing on their systems or accessing via our network. So the benefit of having PPTP is that, one, it gives you more secure communication through encryption for the transmission. So it gives you a little bit of a better layer in the protection, and you can use this as an alternative compared to what we've seen with the dial-up PPPP. If you are connecting over the internet, which most of the people are doing when they're remotely connecting from or working from home, which is what you see, or even a hybrid worker 50% at home and 50% when they come to the organization. They have to go through the internet in order to connect to the network. And that's what we implemented as what we see multi-protocol communication over the public network. So the benefit of PPTP is more compared to what you see with PPP. And then with VPNs, we can use it to establish the tunnel so that way our communication, right, is protected when we are entering in from the internet into our business network. So it's secure the communication, and you know this when you are traveling or when you're using public Wi-Fi, you should be using VPN so that way people don't scan you and see your activity. And PBTP uses GRE, which is called generic routing encapsulation. So encapsulation just means that it prepares your data, right? It's able to set up the information so it can convert your signal to, a certain environment. So for example, if you're looking at your network adapter, it does encapsulation by changing just your electrical signal into a way that we can see, the system can see 0 and 1s, and that's how it's able to send your digital information as 0 and 1s. Now, in different environment, you want encapsulation so that way it will prepare your message or your data so that way it can send. And it would use GRE to do the encapsulation, and then it uses PPP to transport the packet. So that allows it to be able to also efficiently use the virtual private network with encryption. Any question? Okay. I'll leave that for a little bit because some of you are still working on recording the information. So we have about one more unit or so to go. Maybe for week 14 and 15, I have to see on how that works out. I will give you optional attendance so that way if you come, you can work on, maybe optional labs so that way you can get extra credit. But I will not require attendance right before the final exam. My final review is I already have it pre-recorded, so you can watch that. I highly recommend you download the final review. I will turn that on starting next week and go through the questions. Most of the questions came from your assignment. Similar to the quiz, you will have a final exam that's multiple choice, but it's going to be 50 questions. So to better prepare for your final, go through the final review questions. If you get stuck on a certain question, you can watch a video, you can go back and review your notes and also your assignments to be able to prepare. My experience with CIS-40A is that students generally do okay in assignments and stuff because I go over it in class and then sometimes you forget. On final exam, the score for some of the students are not as high as expected, even though they did well for most part throughout the class. Tomorrow I'm gonna try. I have everything set up for automation, so maybe tonight or tomorrow you will receive an email for test out to do the practice exam. You need to also work on that until the end of the semester. So try to work on the Network Plus practice exam throughout, and you do have access to test out for 1 year starting from the activation time. Okay, I try to let you activate it late so that way you can have it after the class. And read the instruction on the email. Do not delete that email because you might need access to it later, right? I cannot guarantee that the program will have more test out licenses after this year. I'm working on acquiring additional funding to be able to support the program, but we don't know how the landscape would be for funding with state and federal in the future. So we're just gonna go as we go, we're gonna figure out how much, and then we'll be able to, ask for support and sponsorship with organizations and things like that. So utilize the resources as you can right now, get as many certification as you need to, especially if you're in the apprenticeship program, okay? Okay, let's move this up a little. Okay, so since we talked about VPN, you know that it implements encryption, but what kind of encryption is it using, right? So when I do a presentation with high school students, I always ask them if they know what VPN is, right? The majority of them kind of know that they should be using VPN. But if you're using OpenVPN, which a lot of the application use, even when you're using the web-based VPN, it uses AES, which is your key length or your bit size is 256. And your authentication is at 2048. And your hash algorithm is 160 bit. So when you are shopping for product that uses encryption, one, you need to check your key length. The longer the higher the bit size of the key, the harder it is to be able to crack that key. Remember that key opens things, right? So you want a length that is adequate. 256 and up will be good, right? But higher would be better. So the standard is that it uses AES, and you see AES in wireless as well, right? It's on your smartphone, it's on your wireless router. And then RSA uses PKI infrastructure. So you have two keys, a private and a public key. And the length for that is 2048 bit. And then the hash algorithm, it uses SSH1. So some of you learned that this in CIS-27, your SHA-1. And it uses 160 bit. So it is decent security, but it is slow, right? As I probably mentioned to you before, I used to teach upper classes, and the solution for most of my former students will be, encrypt it, right? Well, encryption requires resources. It would be efficient, right, if we use an encryption that our system can process quickly. If you have slow systems like lower processor, lower RAM, your encryption is not ideal. And in this case, you're going to face some slowness for most standard system. Now, if I lower the type of encryption and the bit sizes here, right, I would just then become more jeopardized to the risk of getting my key cracked or the break of encryption. So when you see a bit size like this, you know that it's going to take a lot of resources. So it does face some slowness. Now, if you're using, so in most network, we would refer to IP security or L2TP. And when you implement this, when you go through like Microsoft Wizard, it's going to ask you, which one do you want to select, right? Typically, administrator would select IP security. And if you are looking to manage remote access servers, you're going to see this popping up on the job description. So what are the benefits and the disadvantage in this? When you're using IPsec or L2TP, you are also using AES 256-bit encryption. It is by standard advanced, and it is commonly implemented. It is slower than your typical PPTP, but it is safer because it is restrictive when it's bypassing firewall. Because remember, when you're coming in from the internet or the public network, you have to go through the firewall to get in, right? Whether it's application or it's an appliance for border firewall, because you're entering into the network. So it's going to use a fixed port, and if you're using L2TP, sometime you are gonna get blockage, so it might be that restriction, so users, even though they're legitimate users, they might get blocked there. And that might require multiple attempts in order to connect and so on. So that means that if I implement this, right, I need to make sure that I configure the firewall accordingly, or I implemented my security appliances and I filter accordingly so that way, one, my users don't face issues with access restriction. Two, I don't open up a gate for a flood of attacks. And I still have security in my network. So you have to strive that balance, and that can be not easy. Okay. So do I want security? Yes, right? But then on the downside is that I might have issues with blocks. It is a common type of service and protocols that's used for remote access, and you're going to see that abundantly used in infrastructure nowadays. And it does give you throughput. Okay. Any question? So what's the difference between SSH and VPN then? Right? So far, we talked about how we can remotely access a system, but we would use VPN for the connection to protect our communication. SSH connect you machine to machine. VPN connect you to the network. Okay, two different things. Well, you ask, well, isn't the machine part of the network? But you have one entity that is a system, and then you have a network which consists of many entities. Okay. So a network, by definition, is two or more systems communicating across, intercommunicating. That gives you a network. So VPN, virtual private network, in the name, establish a tunnel in communicating into the network, whereas SSH directly connects a system to a system. Got it? I hope that clarifies it, because I see people use it loosely. Okay. So, if you know, you know, right? That's what they say. And if you pass a certification, you must know. Okay. 18. So there are so many different options with VPN. You have a site-to-site VPN. This allows you to connect two or more networks together. So if I have network 1 and network 2, and they belong to my company, I would do a site-to-site VPN so I can establish secure communication, right? So I can have HQ office network and branch 1 network, right? Connecting together, that you would use a site-to-site. And so an example of this, I give you a list of it. You have a site-to-site for corporate to branch. You can also use it to connect private traffic to a private circuit. That's old, right? You would use site-to-site for partners company. So for example, I'm Target. I buy a lot of product from Disney, right? Then I can use a site-to-site to connect to Disney databases so that way I can update and acquire inventory information. So when I'm short on certain Disney product for Christmas, right, Disney is able to supply that automatically because I'm able to sync to their systems, right? So you can do that with partners, with, distribution center, a lot of different things. So site-to-site VPNs is ideal there. So now that comes back to the question, when should you use VPN for remote access? And what type of VPN protocol should you use? Because people often say, oh, we want to implement VPN for remote access, but when, right? When you are using for temporary connection between your users, right, your client system to your server system, typically to be able to access data or applications. Now, in most network environment, you often see that they would go to the IP security type of VPN. And so we would implement this so that way you can use SSL VPN for connection to the gateway. Okay, we clarify SSH, right, compared to VPN. But when you're using SSL VPN connection, do you know what this is for? This is for web interface, right? Secure socket layer uses it's used within HTTPS. So when I open up my browser and I type in the URL for my private network, this is what you see with a lot of web-based VPN, where when you acquire it, you visit a website, you log in, that secure your communication between your system and wherever that you access the internet. It secure your endpoints through a VPN gateway. So they have a bunch of VPN gateways, which are ultimately routers that are configured as VPN. That allows, and so your communication is routed through their gateway to be able to access YouTube, game, whatever that you do on your laptop or on a tablet using VPN. Okay, bless you. So this allows you to have connection through the web with SSL. Question? So now it makes sense, the things that you're using now, right? Your wireless router, your VPN. And the last question, I know you want to get to the lab and some of you probably have to wait for attendance and go. Describe how telenetworkers or remote workers, business travelers can use client-to-site VPN connection securely access the company application remotely. So most of the remote worker, as you know, they are connecting to the network, possibly to access their computer at work or their application, their data, right? So what they do is they use what's called a host-to-host IP security connection. This is established for remote access and also integrated for VPN. So that allows the communication to be encrypted between the teleworker, the remote workers, and the system that they're accessing. And they are both running on the same tunnel. So it actually, if you look at when you look at the header for the packets, it has added fields for security, and that allows the communication to be established, right? Because if somebody is monitoring the network, like if I'm running Wireshark and I'm able to scan your network, when I'm looking at that header, I don't necessarily see, right, raw data or, payload information easily. So that is going to utilize the authentication key, because when I issue the authentication as a user, as a remote worker, and I'm accessing the network so that way I can run my application, it established a session for that particular tunnel. Then the IPsec communication would then pass the traffic using encryption. Okay, so IP security is ideal for remote access infrastructure, right? Your network, and because it's allowing you to have encryption for that tunnel communication between your systems. Okay. Any question?
You about Jump server is a different with VPN.
I'm sorry.
Can you tell about Jump server? You usually use in the Microsoft network. When we use IDP to connect to the Jump server, and then we can go in the network.
Yeah, so jump servers are just middle servers that passes. So you can utilize that to be able to get access to other types of servers, right? Using remote desktop. The way that you would implement that is, one, it uses that to be able to control who authenticates and what, so that way it can divert the traffic. You can also set it up as a transparent proxy. So jump servers typically is a proxy type of server. Yeah. So, and that would either divert the traffic this way or that way, But do you really need that? You can. So in an enterprise environment where you have a lot of different requests for remote access, let's say you have 1,000 remote workers, yeah, that's typically being implemented so that way it is how you can control the flow for your traffic. Yeah, but do they necessarily implement that in every infrastructure? No, I think it's really a design perspective on how you want to control that. With the jump server, I can also monitor that, right? I can make it where it would be able to regulate and see and block and direct and so on. So, yeah. But, if you implement just a typical IP set type of environment, you can just have a few components. So you have to implement authentication, and with Microsoft, you have to implement a ticket granting server, certificate authority server, and then also remote access connection where you can specify who can connect and from where, like IP addresses. Now, this can also be implemented in, you're going to see that today in your security appliance physically on your router or your switches. Any other questions? Okay. So virtual private network, make sure we go through these, make sure we know them for final exam and also our quiz, right? And it shows you how you can configure VPN client on Windows 10. So when you go for an interview and you put VPN down, make sure you know how to set up your VPN, right? I put down the step for you. You go to settings, network internet, click on VPN, add VPN connection. And then, if not, just search for VPN and it will take you to the settings option. And then you would type in the connection. So it walks you through the steps on how to do that for Windows 10 and 11. And then if you use OpenVPN compared to other types, right, like SSTP or IKV2. And then the IPsec that we talked about is here. Different types of VPN. Okay. All right. So now I think that will brings us to the end of our questions. So before we take attendance, I know some of you already started working on the lab, right? I won't be able to demonstrate. I'm going to keep the recording that I had previously because I think I recorded that separately outside of class because the same issue. So for the lab today, you are going to use 2 appliances. I have set those appliances at the desk where you're sitting. When you're done with the 40net, you are going to swap it with the Linksys. I just don't have as many Linksys as the 40net because when we bought it with 2 different budget. And that allows us to get certain products that's more or less. Okay, so let me see, lab 11. So, okay, you are going to use Putty, which is an application that is, so that way you can directly connect to the 40 gate with your console cable. So use the blue cable, connect as shown. Make sure you check your comm. So if you're not connecting, likely that you're on the wrong comm. And your baud rate is 9600. Now, on the newer Cisco devices, this rate is higher, and then you just need to make sure that you configure it, okay? The username should be admin and no password. If it's not authenticating you, likely the person who previously used it did not reset it. So just press the reset button and start over again, right? Try to reestablish, and then you're going to see a terminal window. Press the enter key 1 or twice, and then you can type in the question mark, right? Because it's going to show the terminal with like your cursor blinking, and you're only going to be able to use the keyboard. So just use the keyboard. So at this point, once you connecting to it, you're going to take a screenshot. Now, very similar to Cisco appliance, you are going to do a configure interface, right? Remember how we talked about configure terminal? In FortiGate, you are gonna do config system interface that allows you to access as a privilege mode, and then you are gonna edit the port that you need. This is particular to the appliance. I know that the user basic manual is in the box, but it's probably best if you don't know, then you go to the website and look up the manual from the manufacturer. Okay, so we're gonna modify port 3, 4, and 5. I only give you 3 set because if you modify port 3, it's gonna be the same as port 2 or port 1, right? So just have an idea. So when you edit the port, you're able to configure that port, and then you are going to change your status to up. You're gonna enable that port, just like what we've seen in Packet Tracer, right? We access the port, the interface in Cisco. This is the port, and then we're gonna enable it. We're gonna turn it up. Now you're gonna set up VDOM as root because you want to access it and a higher privilege, and then you're gonna end. That's it. So we're gonna store it to your memory, and then after we configure, so we enable each port. After that, right, we're gonna set up aggregation for your link. We talked about link aggregation last week. So you're gonna edit your aggregate, and then you're just gonna enable that, right? And then you are going to put in the IP address and the subnet mask, okay? And then after that, we're gonna set up our service. I read out the last one, do not use CapWap because it's probably not available anymore. So you're just gonna allow SSH and the other services right here, okay? So these are protocols that it supports for this particular model, okay? And then we're gonna enable device identification for SNMP, and then also 40 heartbeat. And after that, we're gonna finish setting up some role, like for LAN, for local area network, and then your simple network management protocol, because we need to be able to manage these things up and down, determine whether they're up and down and the type of service they're running. And then next and end. So each of the command, press enter, but pay attention to the error and how you type. If you type it wrong, just retype it again. Okay. Then you're going to set up VPN. It's going to walk you through on how to enable network address transversal. We talked about that last week. You are going to enable your secret key, very similar to what you've seen with Cisco. And then you're going to set up your gateway. And this is an IP address for your gateway. Then you're going to make it a static. Then you're going to create another VPN called the backup VPN and another secret key and set up the gateway for it. Why do I do a backup VPN? In the case if my first VPN fail, I have a backup VPN so people can connect. Understand? So you're going to set up your VPN, and notice that we're using IPsec. Okay? Then we're done with that. Close PuTTY. Reset. So shut it down. Press the reset button for the next person so that way they don't have a problem. Answer this question. Get the Linksys router and go through the process. So you are going to connect the Linksys not with the console cable, but with an Ethernet cable. You're going to take out the school Ethernet cable, plug in the Ethernet cable that comes in the box for your appliance. But when you're done, please plug it back, because tomorrow morning, when the other class comes in, they know nothing about networking. And when they turn on the computer and they can't access the internet, they're going to have a problem. And I don't want a bunch of problem in this room. I'm going to hear it from the IT people. So make sure that we follow this step. If your password and username doesn't work, likely that the person didn't reset it. So press the reset when you start and then go through the process. Okay. Go through and you're going to set up some content filtering. Like I want to filter out pornography. I want to block a certain website. So we want to do a little bit of content filter. Then we're going to set up our VPN. We're going to put in an IP address and a credential for authentication. which is what we talked about today, right? And then we are going to set up the encryption key and we're gonna save. We are gonna set up the link sys as a PPTP, whereas the 40 gate is gonna be IPsec. So know the difference, right? We talked about that today. So when you enable PPTP, you still have encryption, but it is not it doesn't have the tunnel similar to what you see IPsec, just different type of protocol and different technology. You are going to add the user account that's going to access the VPN. Then you're going to use an easy link so that way you can just send the link to the user so that way they can easily access it. And then click save. We're going to also enable DHCP so that way once they're accessing the virtual private network, they're able to obtain an IP address. We talked about this last time as well, right, from your scope. And then take a screenshot and answer what you have learned from setting up your link sys. Make sure if you have console cable, return that and put that on top of the box. You can bring the box up to me or you can leave it at your desk, probably best because I have to put it back in the box. And then making sure that you plug the Ethernet cable back for the computer. Save your work, submit it, make sure before you shut it down, remove all your USB and all of those things. Okay, any question for me? Okay, so I will walk around and check on you in case you have problems after you take a break and start your lab. And then please work with the person who sits nearby.